Howdy to whoever is watching this video. I am Dylan Gay of class Chem 117, section 402 at TAMU, and this is my gig chem project. Today I'm going to be discussing the fundamentals of enthalpy related to the common elephant's toothpaste reaction that's displayed at some sort of science shows and stuff. As I am in quarantine, I do not have the resources to conduct this experiment myself as I would have liked to. But I am still going to talk about the science and display it because I found a really good video that displays it pretty much what I would have done. So elephant's toothpaste itself is basically the rapid decomposition of hydrogen peroxide into water vapor and oxygen gas. As I displayed here, it's usually catalyzed by something like yeast or potassium iodide. I showed it here as potassium iodide, and that's going to be shown. And this is how we would usually denote it in class. Here's a normal reaction with the two hydrogen peroxide decomposing into that water and oxygen gas. We're just going to show you what that looks like. Usually how reaction is formed is you have about 30% concentration of the hydrogen peroxide itself mixed with some soap, and then the catalyst comes in and you get something like this. So as you can see, quite a lot of energy is released there, and that is exactly what I can prove is happening with an enthalpy formation equation. As displayed here, as we were in class, I have calculated the enthalpy formation of hydrogen peroxide and the water to get a net enthalpy of a reaction of negative 108 kilojoules per mole. As you can see, that is a negative number, which means it's exothermic, and there is energy being released by the heat of a reaction, in fact. And we can use this further in something like Kirchhoff's law to describe the change in temperature of reaction. And this is very applicable in describing the change in temperature of how hot any sort of exothermic reaction is becoming, which is something that can be drawn that could be quite practical from something like this. Thank you, and Gigam. I hope you like this presentation.